Hello, my name is Bryan Reyes, and today I will be talking to you about section 5.2, which is about reflections, which are the building blocks for isometries. So starting off, the chapter talks about reflections, which, as the book states, is a transformation if a transformation f has the property that some fixed line L is the perpendicular bisector of each segment P to P prime for any point P in the plane, where P prime is equal to f of P, then f is a reflection in the line L. Now what this line L is referred to as is the line of reflection, where one image is reflected across this line to give us the following image down below, which is P being reflected over the center line, which is line of reflection as stated, giving us the new image P prime. So along with reflections are isometries, which according to the book is any mapping of the plane that preserves distances and is therefore one-to-one in a transformation is known as an isometry. So it stands that any function f is an isometry if and only if pq is equal to p prime pq, or sorry, p prime q prime, and this means that this is true only if and if and only if for each p and q, with p prime being equal to f of p and q prime being equal to f of q, that pq is equal to p prime q prime. So looking at the image down below, you can see that the images have been translated across a reflection and are similar in that such, compared to the bottom image, where it goes from one point to a smaller triangle to a larger triangle, which does not represent what an isometry is because it doesn't preserve the distances that were in the original image, which in the bottom case was a point, to a small triangle, where the lines of the smaller triangle do not have the same distances as the larger triangle on the right. Whereas in the top one that is isometric, you can see E to A is the same distance as E prime to A prime, and vice versa with the rest of the distances between the left and the right image. Yeah, sorry. So along with reflections comes the first theorem in the book, which is about the ABCD property. So what this is a set of guidelines and attributes that reflections follow, and have, and each of these attributes have properties and they have properties that the beginning of each of these properties correlates with the A, B, C, and D in the ABCD property. So for A, it's the angle measure preserving, B is betweenness preserving, C is collinearity preserving, and D is distance preserving. And this is true for each and every single reflection that there is and ever could be. Now, along with triangles and reflections, isometries and whatnot, comes positive and negative orientation. So what this is in pure sense of the term, is purely the way you look at the points or the vertices of a triangle, whether it's counterclockwise or clockwise. Now, a way to differentiate the two different orientations is by whether or not you look at it in the opposite, the negative or positive direction, whereas the positive orientation is the counterclockwise on the right, or the clockwise direction, which is the left triangle at the bottom. So like I said, these are the two examples. You can see with the yellow arrows that one goes in clockwise, which is the left, giving us ACB, opposed to the one on the right, which gives us a counterclockwise direction, which gives us triangle A, B, and C. And along with these orientations are two different other attributes, or adjectives to describe these orientations and these translations, is direct and opposite. Now, for whenever a linear transformation is it keeps its orientation, that is what's known as being direct. So linear transformation, if say your original orientation is triangle A, B, and C, and if you're reading it in that direction like this, sorry, the camera's inverted. So say if you're looking at A, B, C, and that is a clockwise orientation, if the transformation afterwards keeps this this direction, then it is known as direct. However, if your original is A, B, C, and for whatever reason you end up with C, D, A, you end up with an opposite orientation, an opposite transformation if it reverses the orientation of the triangle after the transformation. And so one of the last things that is talked about in the chapter is the idea of a composition. So what this is it's essentially the product of two different transformations, whether it's a rotation or a reflection, or reflection and a rotation, whichever order. Either way, it's the product of two of them, where one happens and then another happens immediately, similarly to that of a camera. So whenever you take a picture, you have the original image being one way, and as soon as it gets to the lens, light gets inverted through the lens of the camera, and you end up with an inverted shot. Kind of like when you take a selfie and something on your left ends up on your right, because that's just how the way the light is bent and it's worked. So, and what happens there is you get two different transformations happening at the exact same time. And mathematically speaking, we can see this as GF being G of F, or G of F of P, where P is some point put into F, then put into G, thus showing that there's a composition happening, which again is the product of two different transformations. So, yeah, I believe that is it. Thank you for your time.